Hello, this is Mr. Miller, and this is video number 0160. In this video, we're going to talk about special cases when we're solving systems of equations. As you recall, a system of two equations and two unknowns, like we've been solving, can have one solution where we have two lines that intersect at one point. They might have no solutions. That happens when the two lines are parallel and they never intersect. And we might have infinitely many systems. That happens when the two equations are really equivalent. They're the equation for the same line. So any point on the first equation would work in the second equation because it's the same line. All right, so those are the three possibilities. We're going to learn how to tell which of these a system of equation is. Okay. We're going to start with a special case where the systems have an infinite number of solutions. Okay, so we're going to look at an example here, and we're going to start solving it the way we would normally solve it and see what happens. So this first equation, we're going to multiply by 12, and the second equation, we're going to multiply by 9, and let's see what we get. We're going to get 108x minus 36y equals 72, and for the second equation, 9 times 12 is 108, so we get 108x minus 36y equals 72. Then when we subtract them, we see something happens. Everything cancels out. 108x minus 108x is 0. Negative 36y minus the negative 36y is 0. And on the right side, 72 minus 72 is 0. So if we're solving equations and we come to a statement that where the variables are gone and it's a true statement, we actually know this is a case where there are an infinite number of solutions. Now, we want to be able to recognize this without solving the equation. And one thing we're going to learn is how to tell when one equation is a multiple of the others. The way we can tell is by looking at the coefficients. If we take the ratio of the coefficients of x, 9 over 12, we get 0.75. If we look at the coefficients of the y-coordinates, negative 3 over negative 4, we get 0.75. And if we take a look at the ratio of the constants, 6 over 8, we get the same ratio. So we can check the ratios. If the ratio of the coefficients, all the matching coefficients are the same, one equation is a multiple of the other, and they're really the same line. Okay, so let's practice that a little bit. So our goal is to determine whether these have an infinite number of solutions or not. So we're going to form the ratios for x. This is 2 over negative 3. And I'm going to find the decimal to make it a little bit easier for us to compare. So it's negative 0.666. Repeating. The ratio for y is 4 over negative 6. And if you use your calculator, you get negative 0.666 again. And the ratio of the constants, 6 over negative 9, is negative 0.666. Repeating. These three ratios are the same. One equation is a multiple of the other. So, yes, this has infinite number of solutions. All right, let's check this one. 2 divided by negative 9 is negative 0.22. And 3 divided by negative 7 is negative 0.42. Already I see that these are not the same. So this definitely doesn't have an infinite number of solutions. Okay, so let's learn about how we can check if it has no solutions. All right, so here we have another example. Let's go ahead and try to solve this and see what happens. We're going to multiply this by negative 6. And we're going to multiply this by 9. And what we get is negative 54x plus 108y equals negative 30. Here we get negative 4x plus 108y. It's looking very similar, but this side is different. And now when we subtract them, since the left sides are equal, they cancel. You get 0. But on this side, we don't get 0. negative 30 minus the negative 54 is 24. What we get is a false statement. That's a sign that there are no solutions. The variables dropped out, but we get something that's not true. Now, if we look at the coefficients again, we can tell 9 divided by negative 6 is negative 1.5. Negative 18 divided by 12 is negative 1.5. So the ratios of the x coefficients and the y coefficients are equal, but we see that the ratio of the constant coefficient is not. So then the ratios of the variables are equal, but the constant's not. That's when it has no solutions. Okay, so here's some examples for that. We're going to determine if these have any solutions or not. So the coefficient of x is 6 divided by negative 8, which is negative 0.75. The ratio of coefficients of y, negative 30 over 40, is negative 0.75. Something's up here because so far those two agree. The constant terms is negative 4 over 16, which is negative 0.25, which is different. The ratio of the variables the same, constant different. That means it has no solutions. All right, take a look at this one. 4 divided by 5 is 0.8. 2 divided by 3 is 0.67. Actually, this is not a special case. Okay, so in order to have infinite solutions or no solutions, the ratios of the variables are equal. Okay, so this is actually going to have one solution. So does this system have any solutions? Yes, it will. All right. The last case is kind of the normal case, is when it does have one solution. That happens when the ratio of the x terms, and this would be 2.66 repeating, and the y terms are different. Okay, so when the ratio of the variable terms are different, it's a normal case. It has exactly one solution. And for this system of equations, it would be right there. All right, so we're going to finish by doing 4 examples. We're going to check the ratios and see, do these have an infinite number of solutions, no solution, or exactly one solution? So the ratio of the x's is 3 halves, which is 1.5. The ratio of the y terms is negative 5 over negative 2, which is 2.5. Those are different, so already I know this has one solution. It's a special case if those two are the same. All right, check this one. Negative 4 over 6 is negative 0.67. 10 divided by negative 15 is negative 0.67. And the last one, negative 7 over 6 is, let me see what that is. That's 1.16, or negative 1.16. Ratios of the variables, same. Ratio of the constants, different. This is no solution. All right, negative 18 over negative 24. That's 0.75. Negative 6 over negative 8 is 0.75. 12 over 16 is 0.75. All three the same? This is infinite solutions. All right, very last one. 4 divided by 3. 4/3 is equal to 1.33 repeating. Negative 7 over negative 10 is equal to 0.7. The ratio of the x coefficients and the y coefficients is different. We know already this has one solution. Okay, so a quick summary here. You'll find this in the worksheet you're about ready to do. But a system has infinitely many solutions when the ratios of the coefficients of the x terms, the y terms, and the constants are equal. All three ratios equal. It has no solution when the ratio of the coefficients of the x terms and the y terms are equal, but the ratio of the constants is different. And finally, exactly one solution when the ratio of the coefficients of the x terms and the y terms are different. So, not too hard to do and to check if you kind of know what's going on. It just takes a little bit of practice. And this is an advanced topic on the SAT. All right, you're ready. Go for the assignment. Assignment number 0160 about special cases. And as always, let me know if you need some help. Take care.